Hello, I'm Robert, and this is to help people who are afraid that NASA is lying to us about asteroids, or that they may have made a mistake in their orbits. And so I just want to show how anyone can go online and check these orbits. It's done as a collaborative thing, and astronomers worldwide, they share their observations publicly, and anyone can calculate the orbits. We now have tools. We have amateurs and experts, as well as amateurs too, have developed these software programs. You can just take the observations, you can enter them into the program, you can check, and you can see that the observations do lead to that orbit that was calculated. You can just check that for yourself. So, for instance, if you go and so now if I'm just going to show, you can actually use my Google for Doomsday Debunk thing, the new buttons that you can add to the Google page. If you can control, just click on astronomy, then you get my search page for Apophis, and then you click on show observations. You can actually get to the observations. That's a quick way to get to them. And then if you go and click on download, then you get to those observations, which is in 80 character format, which is very easy for computer programs to read. Then you go and find a program called Find Orb, and you copy and paste. And sadly for Apophis, there's some problem entering all of them, so I just entered a few for 2004, a few for this last year, a few for an in-between year, I think it was 2012. And then you scroll down and you click, you can leave all those things, the defaults, computer orbit and ephemeris. And so I went and did that, and then where is it? And there's the result, and it works out the ephemeris. It tells me where it's going to hit where to look at it. And this shows the right ascension and declination. These are the positions in the sky to position your telescope to look for it. And it shows all the way through in 2022 through into January where to look for the next few days to observe it. And it brings up an orbital viewer, and then in this orbital viewer, now if you switch on the orbits, then those are just approximate. You can see they're really quite way out compared with the actual, but these are the correctly calculated orbits of that's Apophis and that's Earth. And as I said, I didn't have all the orbits, I didn't put all the data, just a few observations from 3 separate years. And that was enough. And I worked, and with that and clicking calculate, I worked out they would be closest on at 10:13. That was on the 13th of April. And that was within, the actual answer is 21:46. So I got within half an hour just by going online and not entering all the observations. Got within half an hour of the correct flyby distance. And now if you go and, so that's the closest point, 0.097 lunar diameters. If I go and click forward, I'll go back. See, that's it, going back. Let's zoom out a bit, and you can see there's the Earth, there's the Moon. So it's much closer. That gives an idea how close it is, far closer than the Moon. So I just play backwards. That's backwards in time. Now I'll stop it. I've set it to go very slow. Let's set it forward. It's all on April 13th. And you will be able to see it with the naked eye back then. See as it flies past. And that's its closest point. And I got it, very nearly gets it right. So, and you can do that. You can just go and copy and paste a few observations at Apophis, put it in, try out this program, very easy to use. And this is a very accurate simulation, although it's the online version, but you can actually download it. And if I go there, but you can download it, and there's more accurate. So this program takes account of the Earth, the Moon, and the Sun, obviously, all the planets, and you can include Pluto if you want. Very rarely that makes any difference. And it also includes, if you want, you just got a checkbox to switch them on if you want with the program that you have to download. And it used to include just the 4 largest asteroids. It now includes the 300 largest asteroids in the asteroid belt and the gravitational effects of all those objects as well. So it can work it out with tremendous accuracy. And I don't think there's a little bit extra information the Centre for Near Earth Object Studies have. They also know the distance, the rate that you can find using radar, which was calculated. So the radio telescopes that they used to communicate with, Perseverance on Mars and the Voyager spacecraft way out traveling towards interstellar space, and all the other spacecraft, the Parker probe near the Sun and so on, they communicate with them with big radio telescopes, and they use the radio telescopes to receive the signals back from them. And that's called the Goldstone Array. It's an array of telescopes all around the Earth that are able to pick up signals from these spacecraft at any time, day and night. And sometimes when there's an interesting asteroid flies past, then instead of sending a signal to us, and they work out the distance of these spacecraft very accurately, by sending them a signal, the spacecraft immediately sends a signal back, and then by the time it takes to go there and back again, they know distance to extreme accuracy. Well, they can do the same with asteroids that flies past. Of course, there's no transmitter on the asteroid, but if it's close enough to Earth, the radar signal, they send a pulse out to the asteroid, and it bounces back, just like with radar bouncing off an aircraft. And so, with these very powerful, huge radio telescopes beaming a pulse at a particular asteroid, focused on that asteroid, and then very sensitively they're able to detect them coming back, like huge, super sensitive radar. And they use that to work out the distance to these asteroids with great deal of accuracy. So that is added on top of all this. So the data that I entered there, and this is the data I entered. Wait a minute, I'll scroll up the page. That's the data I entered on that page. And they give that's the exact time, and then so that's 2012, 29th, and this is a decimal number for the time in the day, and then this is the right extension and the declination. They give the position in the sky, the exact position to point your telescope and where they saw it. So these are the observations, and I showed you how you find them. And these observations, if you go and look at the time when the Apophis was very close, you find lots of observations by amateurs. Some of these some of these telescopes. Some of these are very small, just backyard telescopes when it's very, very close. Like I was in March. That was when it's the closest. And then there were people. Some of these things are just people. If you are a very keen amateur, and you can afford to build one of these small domed observatories, you can actually buy them, I think, and you build them in your back garden, and then you can get one of these telescopes, slightly larger size, that's still within the budget of a keen amateur astronomer, and then you can go and observe these things. And then when it comes to the flyby on the 29th, then even you can see them. You'll be able to see it with naked eye, and anyone will be able to observe it then with very smallest telescopes. And then these observations, if you know how to work out the position from you've got the right kind of telescope, the right way to detect where it's pointing and so on, and work out the stars and where it is, where exactly you're looking at. Then you can submit these observations, and you submit how bright it is, and this helps the astronomers, and you can feed these into these calculations. And it's all public. You would send an email to the Minor Planet Center, and then your observations, you have to register as an observer with them. You get an observatory code, and then using your code you upload these observations, and then they'll appear on that list. It's just, there's no way that anyone can hide anything. And then anyone can go and get SkyOrb, go and use SkyOrb, it's completely free, and they can compute it. And then they can work out where Apophis is. And then you've got these predictions by the Centre for Near Earth Object Studies, and then you've also got the predictions by the Minor Planet Center and many other people. Anyone can use SkyOrb and make their own predictions. Find Orb, not SkyOrb, Find Orb. So I hope you can now see that it's totally impossible to hide an asteroid, totally impossible to lie about its orbit, and it is of course possible. Everybody's human. It's possible to make mistakes, but there are many people who can check and double check these calculations using different software, different methods, and so there's just no way that this is mistaken. We absolutely know that it's not going to hit on the 29th of on the 13th of April 2029. And then this, I just want to explain separately that people have a totally unrealistic idea about how dangerous they thought Apophis was. And if you ask people, what would Apophis do to Earth, then you get people thinking, oh, we'd all die. It'd be the end of Earth. There'd be no humans left. There'd be no life left. And it was so far. That's like being afraid a hurricane would destroy all life on Earth. Because Apophis's effect on Earth is roughly the same. If it did hit, which we now know it won't, it's roughly the same as a hurricane, but a very focused hurricane. And remember I talked about how the radar telescopes, they can bounce signals off to get the distance. Well, if we ever spotted something like Apophis with, say, only 6 months warning, then it would be like a hurricane that you can predict 6 months in advance. And then as early as 7 days in advance, using the radar signals, you can predict exactly where it's going to hit to within 100 meters. And then to give an idea of the sort of damage you get from Apophis, then this is the Earth Impact Effects program from Imperial College London, I think it is. And is it that one? Anyway, you can feed in the parameters for Apophis, and you can feed in what it's going to hit, which in this case is ice. Tell them where it's going to hit. In this case it's Greenland. And then this is what it showed. Well, surely there's nobody surely there's nobody with glass windows in the centre of the Greenland ice sheet. But if they were inside that circle, then the windows of their houses would break, would shatter. Then, if there's anyone living along a little bit of coastline and Apophis hit there, then if they had shells with small objects on them, then some of the small objects would be knocked off the shelves. Outside of that, you wouldn't even get that in Greenland. And then if it hit in the ocean, then if it's say 100 meters wide, or if it's, I'll just talk about a general asteroid rather than just Apophis, then you only get a tsunami if the wave it creates and the wave it creates is similar in diameter to the object where it is in an ocean. And so if it's say 100 meters wide, it's going to create a wave with about 100 meters diameter wavelength. And in order to propagate like a tsunami across the ocean, it has to be 10 or 20 times more wavelength than the depth of the ocean. And the way tsunamis are able to spread so fast and cause so much damage is because they're created by a huge segment of the ocean floor in an earthquake, 100 kilometers in diameter, that shifts up maybe a meter or so, and the surface will maybe like just shift up a few inches, but it's so wide. And then as it arrives to the sea at the coastline, the wave bunches up. And because it's several times 10, 20 times the depth of the ocean, then the wave can spread over the ocean without losing any energy. With something like Apophis, that's only going to happen in a very, very shallow sea, maybe 5, 10 meters deep, 20 meters deep or something, depending on the size of the asteroid. So you don't get tsunamis from these asteroids if they hit in the middle of a deep ocean. And never mind a mega tsunami, you don't even get a small tsunami. You just get ripples that dissipate, and you wouldn't even notice them at nearby shorelines, because there's no tsunami. It doesn't persist. It just the energy of the waves very quickly dissipates. So if you flew very close in a jet, you'd see a huge splash. It would go up hundreds of meters, depending on the size of the object, and splash down as a big hole in the ocean would form suddenly. The splash would fall into it, and then you get a secondary droplet comes up, just like you do with those pictures of droplets falling in the seashore, falling in water. And if an asteroid hits, you get that. You get the big splash at the side, you get the secondary droplet that comes up and then falls down. You get a long, complicated thing, and then it just ripples off, and it's soon gone. And it would be quite spectacular to watch if you got a big asteroid, 100 meters across, say, big, totally harmless, if it fell in the middle of the Pacific or the middle of the Atlantic. So even if you spotted something like Apophis in advance, if you knew that it was going to hit an ice sheet or the ocean, there's no need to detect it. Just tell people to keep out of the way, and astronomers will be very, very keen to study it and see what happens when it hits Earth. So, sadly, you would only know it that accurately within, well, you'd know it. But anyway, if you wouldn't know it that accurately a decade in advance, so sadly you can't really say, unless you were to have a little thing on the asteroid, deliberately steering it into the Pacific Ocean or into Greenland or something, and you could have little things with jets on it. But anyway, yes, maybe sometime in the future, then when we have lots of technology and lots of spacecraft and things, we might actually do that with some big asteroid like that when it is approaching Earth, and say, once we're supremely confident in our space technology, you could say, well, it's 100 meters across. It'll be very interesting to see what it does. If it is Greenland, let's just let it do it. It's that sort of but anyway, it's that sort of a level. Remember, you can evacuate a city with only 2 days' notice for a hurricane. So even if something the size of Apophis was hitting a city, and you knew it was going to happen, nobody's going to die if you're tracking it. You have far more warning than you have for a hurricane. And they're extremely rare. So there's never been anything like this in all recorded history. All written history. Sumerians, the Egyptians, the ancient Greeks, the Romans, the Chinese, the various cultures in India and Afghanistan, Turkey, and some very ancient cultures in Turkey, African kingdoms, the kingdoms in South America, the Mayans and so on. None of them ever recorded anything like this. Just never happened in all those civilizations. So why should it happen this century in our civilization? It's not exceedingly unlikely. The likely wait time is tens of thousands to hundreds of thousands of years for something the size of Apophis. And if we did notice one that even if there was an impact this century, it's exceedingly unlikely that we don't notice until the very last 6 months before the impact, because Earth is exceedingly tiny. And if you look at, say, if you had, say, if you passed 1,000 times the diameter of Earth, which isn't very far in astronomical terms, then that would, well, let's say, even 100 times the diameter of Earth, which isn't very far in astronomical terms. Then, if you look at the area of the Earth as a target, and the area of the distance that it could fly is flying past, then it's 100 times wider, so it's 10,000 times the area. So for every 10,000 times that an asteroid flies past at 100 times the diameter of Earth, so that would be 600,000. I mean, it's less than, that's about double distance of the moon, I think, if I've done it right. Anyway, never mind. 100 times the diameter of the Earth. Every 10,000 times an asteroid flies past at that distance, it would hit only once. So you expect, on general, dozens and hundreds and thousands of flybys that you detected for every one that it hits. So if we do find a big asteroid that could hit sometime this century or next century, then, don't mean that big, but big as Apophis, you expect to spot it, far more likely spot it during a flyby than spot it just as it's coming for its impact. And it's just very unlikely that we have anything like that at all. There are many more of the smaller asteroids than there are bigger ones. It's like that with just about all astronomical objects. The small star, the most star. The shooting stars, they're extremely numerous, tiny specks of dust. And the fireballs, which are a little bit bigger, a few meters, they're a little bit less common, but they happen many times a year. And then the ones like Chelyabinsk, they happen maybe every century or so. And we expect maybe possibly even several times a century. We don't. Very hard to get the statistics. And then the larger ones would have to be a few thousand years, something like Apophis, tens of thousands to hundreds of thousands of years is the expected time to wait. So by far the most likely thing that we're going to have as the next impact, so they've already predicted several very small fireballs, and just a few days before impact, and then they impacted, and they can't do any harm. They didn't do any harm, they were just spectacular light shows. And the most likely next asteroid impact, because most of the Earth is either ice sheet or ocean or like the Siberian grassland, grasslands, pastures, and the big nomadic areas of Mongolia and so on, the big deserts, the forests. Most of the Earth's surface is sea, and most of the surface that isn't sea is uninhabited land, or sparsely inhabited with a few herders, reindeer herders and such like. And the actual urban areas of our planet, even today, are very small indeed, and only 1% of the total Earth's surface is urban. That means that for every 100 impacts of a certain size, only one hits an urban area. So if you have an impact size of Chelyabinsk, and suppose that happens every century, then for every 100 of those, which would be every 10,000 years, you'd expect about one to happen to actually hit an urban area. And then you'd have a fair few that would have shockwaves that hit urban areas. So it just happened with Chelyabinsk, where the main danger is flying glass. And most of them, nearly all of those ones, then they wouldn't hit anything. They just hit the ocean or the desert, or ice sheets, or bits, or maybe some grassland with few herders that we'd have to watch out for. And in 1908, then 3 reindeer herders were killed, sadly, by an asteroid and a herd of reindeer. And middle of the last 20th century, then, and these were rather small asteroids, the bigger one in 1908 and the smaller one in the middle of last century hit, killed some people in a small hamlet in Mexico. There's never been a death by impact in the United States in written history. And there was one lady who had a very bad bruise on her thigh. So bad that she had to go in hospital, and she had a lot of lingering problems from this bruise on her thigh from an asteroid. And that's the only example of injury by asteroid in the United States. Of the 300 million people in the United States, you get 20 people every year out of those vast numbers of 300 million get killed by lightning. You have one person every few years that gets killed by a very large hailstone. If you see hailstones so large that they're causing dents in cars, a very rare thing to happen. Obviously, don't go out in that. It's not safe. And way back when it's a very rare thing, but it does happen in the States sometimes, and in most places it happens. And in the old days, when there were lots of farm labourers, it was quite a risk. And also when there was soldiers marching around and they didn't have cover to go to, then it was quite a risk for soldiers who spent a lot of time out of doors. And so quite a lot of farm workers were killed by hailstones back in the day. But nowadays farmers go out with their tractors, which is very good protection from hailstones, and you don't get many deaths from them at all. And but the death of an asteroid is far, far rarer than either of those. And the personal risk is just not a consideration, not a thing you need to be scared of at all. And you never need to be scared of things like Apophis. It's good that we're doing it as a society level thing, because when you've got 7 billion people, and even if it's a very rare thing that happens only every few tens of thousands of years, still, you want to be prepared. You want to be able to deflect it if it's needed, even if it's a very low risk, but just a very, very tiny risk, far less than that. This happening every tens of thousands of years, and remember, 99 out of 100 times it's not going to hit an urban area, so it might hit quite close to them once sometimes, and but still there's a very, very tiny risk. But when you've got 7 billion people, it is worth an entire planet to think about. It is worth spending some of your budget on searching for these things and deflecting them, and making sure you can deflect them. And it's one of these very low probability, high impact scenarios. And when you're dealing with a very large population, it is worth putting in the funding to avoid these things. And it's unlike, there'll be hurricanes every year, create the same amount of damage, but you can't deflect a hurricane. You can only predict it, and yet we put a huge amount of effort into predicting hurricanes and helping people to get away from them and so on, and making the buildings more hurricane resistant. When it comes to asteroids, then if the asteroid, unlike a hurricane, you can predict it, that's a possibility of it decades, even centuries in advance. You can have the exact point of the impact to within 100 meters 7 days in advance, which you could never do with a hurricane, giving loads of time to evacuate, plenty of time to send mobile phone messages to all the reindeer herders in the area, all the explorers in Greenland, and say, don't go exploring the Greenland ice sheet, and don't go doing your meteorological measurements on such and such a date, because this 100-meter diameter asteroid is going to hit, and you can go and observe it from a distance, but don't go close, because don't go within so many kilometers of this very specific point, because that's when it's going to hit on that particular day. And that's the most likely thing that you're going to need to do. And it's just a remote possibility. You might have the risk of broken glass with Chelyabinsk if there are any nearby settlements, and exceedingly unlikely that it's actually going to hit a sort of built-up city. Never happened in all of recorded history that something like that has hit a bit built-up city. So anyway, hopefully that gives you a much more realistic perspective and not so scared of these things. I mean, there's so much nonsense on YouTube and in blog posts. People going on and on and on about this Apophis thing. And this is the reality. Those other things are just fantasies by people who've never looked at the astronomy, never read up, never read any of the papers, never looked up and tried to find out how astronomers do the tracking, never read any of the things that I read when I do my fact checks. And then they write these clickbait videos and people share them, and they call themselves fancy names like Mr. Scientific and Top Man 2, and people think, oh, this person calls himself Mr. Scientific, so he must know all about science. Knows absolutely nothing about these things. And someone else calls him Top Man 2, and because he's called Top Man 2, he's the top man in the world to tell them about asteroids. And he knows absolutely nothing about it. Never, probably, they just don't. These people just don't have a clue. And then they're out scaring people, and possibly themselves as well, with their complete lack of knowledge. So please don't be scared by these people with idiotic ideas. I'm not saying they're idiots. I'm not saying these people are idiots. They probably, they may be very good, they may be very knowledgeable, they may know a dozen languages, they may be able to count backwards in Swahili and Chinese and Japanese and Russian. They may be able to do run up walls and then do somersaults. They may be able to juggling with 10 balls at once, or juggle with three knives and never hurt themselves. But who knows what their talents are? But their talents do not include any knowledge about asteroids, or any knowledge about astronomy, or any knowledge, and they don't have even kindergarten level of knowledge about these topics. I mean, a keen astronomer or maybe kindergarten, when I was probably 12 or 13, I knew more about astronomy than they do. Just from being keen about it and reading the astronomy books that a child can read. These people just don't have a clue. So please don't be scared by these people who are just completely clueless. Don't have a clue. So I hope this helps you be a little bit less scared by all this.